Hello everyone, my name is Dr. S. Pavan Kumar Reddy, Department of Artificial Intelligence and Data Science, PV Raju Institute of Technology, Narsapur campus. I teach the course is data structures using Python. In the topic, one of the most important topic is how to implement the stack. The stacks can be implemented by using two ways. First one is the stacks can be implemented by using arrays. Second one is the stack is implemented by using linked list. Before going to implementation of the stack, first we can define the stack. What is the recap the topic? Stack definition. Stack definition is what is the stack definition? It is a LIFO order. Can perform the LIFO last in first out. Which element will be insert the last? That element will be removed from the first. What are the operations from the stack? We are using it mainly two operations. That is push or append. Second operation is pop. Push means you can inserting the elements to the stack. What is the meaning of pop? We are remove the element from the stack. That is the stack definition and operation. The stacks can be implemented by using the two ways. What are the two ways? Arrays and linked list. Can study the one by one. The first one is how to implement the stack by using arrays. Here, the stack can be easily implemented by using arrays. Initially, the top of the points at the first position are locate the array. Top of the position means the first element, next element, next element. That is the location of the array. Now, we can insert the new elements to the stack. The top keeps incrementing. We can inserting the elements is one by one. That will be incrementing by 1. That is the top will be keeping the incrementing. That always pointing to the position where the next element will be inserted. Next element will be inserted. Here, this is the simple example of stacks using arrays. Here, first we can insert the element 23. Next, we can insert the element 54. Now, first to insert the element is 23 na, the top, this is the top. Next time, we can insert the element is 54, the top position will be incrementing by 1. Top position is incrementing by 1. Next, 120 item is inserting to the stack, the top position will be incrementing by 1. Next, the 87 element will be inserting to the stack. The top position will be incrementing by 1. Next, 98, the top position will be incrementing by 1. Next, 15 element will be inserting to the stack. It will be top position will be incrementing by 1. Now, in the stack, the top of the position is this one. Here, in the array, the array start with 0. Initially, the array will start with 0. This can be representation of the array in that stacks. Here, array of 0, array of 1, array of 2, array of 3, array of 4, up to how many elements are available in the stack, that position. That is the implementing the stacks using arrays. Next one is to implement the stacks using the linked list. Linked list. Here, the linked list having the two parts. This is the node. The linked list having the two parts. First part, second part. The first part can be contain the node, information node, information node. The second part can be store the address of the next node. Address of the next node. Here, the linked list having the representing the node having the two parts. First one is the information of the node. The second part is representing the address of the next node. That is next element in the linked list. Similarly, we can also implement the linked list. We can also implement a linked list by using the stack. Now, it can be represent the stack in the linked list that becomes the top of the position in the linked stack. Here also we are using the insert and delete operation. Okay, these two operations can be done at the node pointed by the top only. The top only. See this example. Here the linked list having the two parts already discussed. First one is information. Second one is the address of the next node. The address of the next node. Whenever to insert the another node, this another node address will be mentioned with the first node. Here the top position will be given to the starting node. That is the implementing the stack. Now we can see the operations in that linked list by using either push operations or pop operation. Push operation means we are adding the element to the linked list. We are adding the element to the linked list already in that existing stack. Okay. Now the new elements in the stack will be always inserting the topmost position of the stack. Initially, we can check whether the top is null. Whenever to inserting the elements, after inserting the elements, whether the stack is empty or not means, if the whether we can check the top equal to null means if the condition is true, the stack is empty. Top equal to null, the condition is true, the stack is empty means there is no elements in the stack. Otherwise, the new memory is allocated to the new node. New memory is allocated to the new node. See this algorithm. This is the algorithm for the push operation using the linked list. Initially, you can start the node. If the second step is new node dot information. If we are inserting the new node, the new node information is available. The information will be given to the value. Given to the value. If top equal to null means set new node dot next equal to null, set top equal to new node. Else new node dot next equal to top position. The top position is new node. The top position is new node. Exit the algorithm. Exit the algorithm. That is the algorithm for the push operation. Next, see this example. This is the example for the stack operation using the linked list under the push operation. Now, first we can apply the push operation. Consider the linked list with 4 elements. Here, there is a 4 elements are available. First 12, 28, 43, 69. 4 elements. A new element is inserted in that stack. New element is inserted to the stack means before the insertion. Okay. That is the before insertion means 12, 28, 43, 69. That is the stack. Whenever to insert the element, new element, that element will be inserting to the starting position. That is called as the top. New element in the stack, the updated stack becomes this one. Here, the X can be represented means there is no another new element is not available in that linked list, that will be treated as empty. See this pop operation using the linked list. What is the pop operation means? To remove the elements from the linked list, from the existing stack. Simply, the pop operation is a process of removing the elements from an already existing stack. The elements from the stack is always deleted from the node pointed by top. Node pointed by top. Initially, we can check the node top equal to null. If the condition is true, then the stack is empty. The stack is empty, which means we cannot delete any element from it. Cannot delete any element from it. This is the algorithm for pop operation. Initially, you can start if the top equal to null, underflow error condition will be displayed. We are creating the one temporary variable. The temporary variable is creating the top position. The top position is top dot next element. Next element. Next can free the temporary variable and exist. These steps can be followed the pop operation. See this example. See this example from the pop. Consider the linked list having the 5 elements. What are the 5 elements? 10, 12, 28, 43, 69 elements are available. To display initially these elements. Now, an element will be deleted from the stack. One element will be removed from the stack means which here initially the stack having the top position, the 10th element is the top position. After the perform the pop operation, which element will be removed first? The 10 element is the top position, that is the starting one. That element is removed from the stack, means this element will be removed from the linked list. So, after removing the linked list, which elements are available in that linked list? 12 node, 28, 43, 69. 12, 28, 43, 69. If the top position is, will be jump to here. Here, the top position is jump to here. That is the pop operation. See this entire Python code for the implementation of the stack using linked list. First, what is the definition of the linked list? The linked list having the representing the node. The node having the two parts. First part is the node information. Second part is the address of the new element. Address of the new element. First, we can create the node. That node can be creating by using class node def self comma data. Self data is a data can be mentioned, means this one is the data. Next node is not there. Whenever to inserting the new element, at the time only it will be linked to the next element. Now the stack class using the linked list having the initially self dot head equal to none. This is the top position, initially the top position. Now we are apply the is empty method. Is empty method means whether the element will be empty or not. Now if the element is empty, no problem. If the element is not empty, to return self dot head is none. Now we are apply the push and pop operations. Push operation method is this one. Pop operation method is this one. Peak is a top of the element will be displayed in the linked list. This is the display method. This is the sample example. Okay. This is the push operation. Whenever to insert the new element to the linked list, new node equal to node of value. This new node dot next equal to self dot next, means it will be jump to the next node. Whenever to inserting the new element, it will be jump to the here. Self dot equal to new node. Self dot head means the head node is the new node. That is push operation. Next, pop operation means in the pop operation, first you can check the whether the linked list is empty or not. Now we are apply the is empty method. Cannot, if the stack is empty, cannot perform the pop operation. If the linked list having the none, the pop value equal to self dot head dot data. Which element will be removed from the linked list? That will be pop value. Self dot head means self dot head dot next means it will be move the head to the next node. Return pop value. Next, can check the peek operation. Peek operation means whether the stack linked list is empty method. The stack is empty, nothing to the peek means we have to not decide the top position. That's the position of the element. Return none. It can be written self dot head dot data. That is the peek method. Next, to display method means diff display current equal to self dot data. Now we can apply the whether the linked list is empty or not. Stack is empty. Return top to bottom. While current position is current dot data equal to ending. The current position is current dot next to print. This is the display method. Now we can check we can inserting the element one by one. See, first we can create the stack. That is in the using implementation stack using linked list na first element is 10. Second element is inserting the 20 means the second element will be inserting the 20. Next, the third element is inserting 30. 30 means push 10 means analyze this one 10, 20, 30. Okay, this is the stack. Now we can display the elements means we are using the display method. See, top bottom. To display the elements from top to bottom. Top position is 30 means 30, 20, 10 elements will be displayed. Now peek method will be applied. Whenever to apply the peek method, it will be goes to here. Peek method. S dot peek. S dot peek means peek 30. Peek 30 means the top element will be displayed. That is 30 element will be displayed. Next, pop S dot pop. Pop element is 30 means to remove the 30 from the stack. Remove the 30 from the stack. Okay. Next, yes, peek after pop. Peek after pop means the top position is 20. Top position is 20. Now, S dot display means 20 will be displayed. Next, pop, S dot pop. Next, S dot pop. Two elements will be removed from the stack. Now, to display the stack. Next, pop. This is the empty means cannot pop element from the stack. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.